sometime next year, a humanoid robot is going to make a split-second decision that, well, prevents a total disaster. Or, an autonomous car driving you through a severe blizzard is going to recalculate its route just in time to avoid black ice.
Right, and the underlying reason those machines will actually be able to do that without their internal systems completely crashing, is it's actually buried inside a really dense, jargon-filled financial document released this morning.
Yeah, it's wild. Welcome to today's deep dive. If you're joining us, our mission today is to look at a freshly released document from GlobalFoundries or GF.
Exactly. This is their first quarter 2026 financial results presentation, hot off the digital presses today, May 5, 2026.
Now, on the surface, this is a lot of acronyms and bar charts, but what we're going to do with you today is decode exactly what these numbers tell us about the future of global technology.
Because really, what is printed in this report dictates the future of, like, the smartphone in your pocket, the data center powering your internet, and, yeah, that autonomous car in your driveway.
It really is a roadmap, isn't it?
Oh, absolutely. Earnings reports from semiconductor foundries, which, are those massive, ultra-clean facilities that manufacture chips. They're essentially the closest thing we have to a macroeconomic crystal ball.
Because chips are the foundational layer.
Right. You literally cannot build the future of tech without them. So by tracking exactly where GlobalFoundries is placing its multi-million-dollar bets today, we can see where the entire global tech industry has to go tomorrow.
Okay, let's unpack this, because before we can get to the robotics and the smart glasses, we really have to look at the financial engine making it all possible. Let's look at the raw data for Q1 2026.
Yeah, let's get into the numbers.
So GlobalFoundries hit $1.63 billion in revenue, which is up 3.1% year over year. They hit 40 cents on their non-IFRS earnings per share, so that's an 18% jump from last year.
Which is solid.
It is, but there is a specific metric here that seems to be like the linchpin for everything else. Their non-IFRS gross margin jumped to 29.0%.
Yeah, that's the big one.
The report points out this is a 510 basis point increase year over year, which is the largest expansion in over 3 years. Oh, and they also repurchased $400 million of their own shares out of a $500 million authorization.
I'm glad you brought that up because that margin expansion is the most critical number in the entire first section of the report.
Well, I want to stop right there, actually, because if you're not a financial analyst, terms like non-IFRS, margin expansion, and basis points sound like a completely foreign language.
Fair point, yeah.
I know basis points are just hundredths of a percentage point.
Yeah.
So 510 basis points just means a 5.1% increase in their margin. But explain the mechanics here for us.
Sure.
My instinct is to use like a bakery analogy. Is this like a bakery realizing they can buy their flour and sugar for way cheaper, so without selling any extra bread, their profit on each loaf suddenly skyrockets?
Let's refine that analogy a bit.
Yeah.
Because in the semiconductor world, it is rarely about the raw ingredients getting cheaper. Sand and silicon are already pretty cheap.
Right.
It's actually about the manufacturing process. When you're printing billions of microscopic transistors onto a silicon wafer, the process is incredibly fragile. Mistakes happen. Dust ruins chips.
So it's not the flour.
No, margin expansion in a foundry is less about finding cheaper flour and more about, well, perfecting your oven. So instead of burning 20% of your loaves, you're suddenly baking perfectly usable loaves 99% of the time.
Okay. So it is a yield improvement. They're getting more sellable chips out of the exact same amount of raw material and labor.
Precisely. And just to clarify that term you mentioned earlier, non-IFRS, that simply means they stripped out the one-time unusual accounting events so that you and the listener can see the actual operational heartbeat of the factory.
Got it.
And that heartbeat is incredibly strong right now. Operating at a 29% gross margin means they're generating serious cash. In fact, they reported $233 million in adjusted free cash flow for the quarter.
Which is the actual cash they have on hand to deploy.
Right. And they aren't just sitting on that cash either. That efficiency is what provides the capital to expand manufacturing capacity in highly demanded tech corridors.
You're reinvesting it.
Exactly.
Yeah.
They're taking the profits generated from perfecting that microscopic silicon yield and funneling it directly into the physical world.
Which brings us perfectly to the automotive sector. When you look at the report, they are funneling a massive amount of resources into cars and physical infrastructure.
Oh, absolutely massive.
Yeah, their automotive revenue hit $382 million in Q1 alone. That is up 24% year over year. And they're projecting a sixth consecutive year of double-digit percentage growth in 2026.
Which is a huge streak.
It is, but what really stands out is that they aren't just making the basic chips to, roll down your car windows anymore. The revenue diversification includes cameras, Ethernet, radar, and power systems.
Well, you have to remember, the modern electric or autonomous vehicle is essentially a massive data center on wheels. And to secure the growth of that market, GlobalFoundries is making some really aggressive structural moves.
Like the Renesas deal.
Yes. The report highlights a multi-billion-dollar strategic partnership expansion with Renesas.
Right. The quote from the Renesas CEO, Hidetoshi Shibata, is actually quite telling. He specifically says this partnership ensures a stable, long-term supply of semiconductors, which are essential as we deliver advanced solutions, with demand for electrification and connectivity accelerating worldwide.
Notice the emphasis there on a stable long-term supply.
Mm.
This Renesas deal is fundamentally about accelerating U.S. manufacturing. There's a massive industry-wide push to onshore the production of essential technologies right now.
So bringing it closer to home.
Yeah. GlobalFoundries is positioning itself to manufacture semiconductors for the top 3 automotive microcontroller unit, or MCU players globally. They're building a localized, physically secure supply chain so that the auto industry isn't entirely dependent on overseas fabrication.
That makes total geopolitical and economic sense. The report states it is auto-grade 1 ready, has a sub-10 nanosecond read speed, and boasts a 500,000 cycle endurance. But then it explicitly targets, and this is a quote, self-learning entities like autonomous vehicles and humanoid robots.
It sounds like science fiction, right?
It does. And my mind immediately goes to the vertical toll that kind of application takes on a computer chip. If you put a computer in an autonomous vehicle navigating a pothole-filled road or a humanoid robot carrying heavy boxes, how does this specific EMRAM technology survive that?
That is the exact engineering hurdle the industry's been trying to solve for years.
Yeah.
When you take a computer out of a nice climate-controlled server rack and put it inside a humanoid robot, you expose it to a remarkably harsh environment.
Lots of vibration, heat.
Yeah, and electromagnetism. Traditional memory chips like the RAM in your laptop, they store data using microscopic trapped electrical charges.
Right, ones and zeros are represented by whether an electron is there or not.
Exactly. But here's the problem. What happens when you place that traditional memory chip right next to the massive, powerful electric motor of an EV, or, the high-torque servo of a robot arm?
Oh.
Those motors generate intense electromagnetic fields.
Oh, I see where this is going. The magnetic field from the car's own motor could literally wipe or flip the electrical charges in its own brain.
It absolutely can. The ambient electrical noise can completely corrupt the data. That is exactly why EMRAM is so revolutionary for physical AI.
Okay, break that down for us.
So the M stands for magnetoresistive. Instead of using electrical charges to store the ones and zeros, EMRAM uses tiny magnetic states. It is essentially relying on physical magnetic alignment, which makes it fundamentally immune to getting scrambled by external electrical or magnetic fields.
Wow. So instead of trapping an electron in a microscopic bucket, you're basically flipping a microscopic compass needle that locks into place and just ignores the electrical chaos around it.
That is a great way to visualize it, yeah. Combine that stability with their FDX platform, which is a manufacturing technique called fully depleted silicon-on insulator that drastically reduces power leakage, and you get a chip that is tough, runs cold, and uses very little battery.
That's a powerful combo.
It really is. That sub-10 nanosecond read speed means the autonomous car can access its memory and make a decision almost instantly without the system hanging. That is literally the difference between stopping for a pedestrian and a catastrophe.
No room for lag in a car.
Exactly. In fact, Dr. Dominic Erb, a VP at Bosch, is quoted in the report specifically welcoming this technology for the speed, endurance, and reliability it brings to next-generation MCUs.
So securing this manufacturing onshore isn't just about business revenue. It's about physically securing the hardware that will allow humanoid robots and autonomous cars to operate safely in our neighborhoods without glitching out.
Precisely. It is the foundational safety layer of physical AI.
And if we have millions of autonomous cars and humanoid robots navigating the physical world, they are going to generate oceans of data. I mean, an unimaginable volume of information that has to be processed instantly.
Mountains of it.
Yeah, and to handle that, the infrastructure of the internet itself requires a fundamental upgrade, which brings us to the data center numbers in this report. GlobalFoundries reported that their communications infrastructure and data center revenues spiked to $230 million. That's a 32% increase year over year.
And that segment is only going to accelerate.
Yeah.
They noted they are on track to double their silicon photonics revenue in 2026.
Okay, here's where it gets really interesting. We need to dive into the technology again because they announced the introduction of something called SCALE. SCALE.
Right.
The acronym stands for Silicon Photonics Co-Packaged Advanced Light Engine. The report says it integrates an XPU die, an electronic IC, a photonic IC, and fiber arrays. Let me try to translate this and you tell me where I'm off.
Go for it.
So XPU is basically just a catch-all term for any processing unit like a CPU or a GPU. And IC is just an integrated circuit.
That's correct.
Right. So if we think about traditional copper wiring moving data around a massive AI server farm, copper relies on pushing electrons. That feels to me like trying to move 1 million messages across a city using a fleet of heavy, slow diesel mail trucks.
I like that.
It creates friction, it causes traffic jams, and it generates an enormous amount of heat. So moving to silicon photonics using actual lasers and light, is that essentially replacing the mail trucks with someone flashing a laser pointer in Morse code? It's massless, it generates no heat, and it moves at the speed of light.
That mail truck versus fiber optics analogy hits the exact constraint the industry is facing right now. When we look at modern AI data centers, the bottleneck isn't necessarily the math capability of the chips anymore, it is heat and bandwidth.
Because the copper just gets too hot.
Exactly. Pushing electrons through copper wire generates so much physical heat that data centers have to spend a fortune just on cooling systems to keep the buildings from literally catching fire.
So where does the co-packaged part of SCALE come in? Because we've had fiber optic cables for the internet for a long time.
We have, but historically, the fiber optic cable comes into the server rack, and then it gets converted back into electricity to travel across the motherboard to reach the processor.
Ah, so it slows back down to truck speed.
Yes, that electrical journey across the board is your traffic jam. What co-packaged means is that GlobalFoundries is integrating the photonic integrated circuit, the actual microscopic lasers, directly alongside the electronic brain of the chip itself.
They're putting the flashlight right inside the brain.
Yes, they are entirely bypassing the long copper roads. The report notes their integration with the advanced microfoundry, the GF Science Park, is specifically on track to support this.
That's incredible.
By combining the light engine directly with the electronic chip into one single package, you drastically reduce the power needed to move data. You eliminate the heat generated by traditional copper traces, and you move information off the chip at the speed of light.
Which solves the heat problem.
Without this transition to silicon photonics, the sheer energy demands of training future AI models would quite literally melt our data centers down.
It really is the only physical way forward for the internet. Okay, so we've looked at the massive infrastructure shifts, the scale technology for data centers, and we've looked at the EMRAM for automotive and robotics.
Right.
But if you look at your smartphone right now, the numbers in this GF report suggest that piece of glass in your hand might actually already be a relic. Let's look at their consumer tech numbers because they tell a surprising story about transition.
The consumer device data is arguably the most revealing part of their long-term strategy.
Smart mobile devices is still their largest segment, making up 34% of their total revenue mix. But it actually dropped 5% year over year to $558 million.
And that's not the only drop.
No, it's not. Home and industrial IoT, the Internet of Things, took a steeper hit, dropping 22% down to $255 million. If automotive and data centers are booming, why is the core business of mobile phones and IoT dropping?
It's a fair question.
Should we view this as a failure to capture market share? Or are we as consumers just finally reaching a plateau with the traditional smartphone? Are we just waiting for the next big thing?
Well, it is heavily driven by market saturation and an inventory correction phase. We are in a transitional period between primary form factors right now.
Okay.
If you read the end market commentary in the report, GlobalFoundries is not acting like a company in panic over a 5% dip in traditional mobile. They're deliberately playing a long game, positioning themselves for the hardware that replaces the smartphone.
That makes sense when you see what they are actually designing for. The report explicitly highlights that they secured 2 new design wins on their FDX platform for micro-LED backplanes that are used in smart glasses.
And that is a fascinating engineering challenge.
How so?
Well, the traditional glass rectangle smartphone has a massive battery compared to a wearable device. But if you want a pair of lightweight, normal-looking smart glasses, that overlays AI-generated graphics onto your actual vision. You need a micro-LED display that is incredibly bright, coupled with constant wireless connectivity to the cloud, all running on a battery the size of a pill.
Wow. Which requires extreme power efficiency and strong RF or radio frequency performance to maintain that constant connection without draining the battery in 20 minutes.
Exactly. That extreme low power requirement paired with high RF performance is exactly what their FDX platform is engineered to deliver.
I see.
They expect the smart mobile device segment to gradually transition away from traditional handsets and begin benefiting from these new AI-powered form factors, smart glasses, advanced hearables, and next-generation wearables.
And on the IoT side, while it dropped 22% this quarter, they explicitly stated they expect IoT to be a primary beneficiary of the burgeoning physical AI revolution.
Yeah, that was a key phrase.
They noted nearly 50 new design wins in the first quarter for IoT, and they referenced a partnership they signed back in March with Innova Semiconductors to deliver a robotics control reference platform.
That signals they believe the industrial inventory glut is normalizing. They're treating this as a foundational rebuilding phase.
Building the runway.
Right. The company is heavily betting that AI-powered wearables for consumers and physical robotics for industry will become the new growth engines to replace the traditional smartphone cycle.
And does the data back that up?
If we connect this to the bigger picture, their financial forecasts reflect this exact confidence. Their Q2 guidance expects revenue to climb back up to around $1.76 billion, and that projection heavily relies on these emerging sectors beginning to scale up production.
So we have gone from the macro financials of yield improvements all the way down to the microscopic magnetic compasses in EMRAM and the micro LEDs in your future smart glasses.
That's a lot to take in.
It is. When you really decode it, this Q1 2026 report from GlobalFoundries is not just a spreadsheet of billions of dollars. It is a highly detailed mechanical roadmap of the next 10 years of human life.
It really is.
We see a 29% gross margin creating the capital needed to strictly fund the future. We see scale technology replacing copper with lasers to prevent our AI data centers from overheating. And we see memory chips rendered immune to magnetic fields ready to be installed into the autonomous cars and self-learning humanoid robots that will navigate our streets.
Yeah.
So what does this all mean for you, the listener?
It means we are undergoing a fundamental shift in our relationship with the physical world and the infrastructure required to support it. Throughout this deep dive, we've explored how chips are no longer just calculators. They're being explicitly designed to withstand the harsh, chaotic environments of the real world for self-learning entities.
Taking them out of the clean rooms and into the dirt.
Exactly. And simultaneously, we are seeing a massive, multi-billion-dollar geopolitical race to onshore the manufacturing of these chips with partners like Renesas. We are rapidly moving away from an era where semiconductors simply ran applications on a glowing screen in your hand.
Right.
We are entering an era where highly specialized silicon acts as the synthetic nervous system of our physical reality.
It is a profound transition. Consider this thought as we wrap up. If a country's entire infrastructure, its transportation grid, its data networks, and its physical labor force of robotics all absolutely rely on these highly specialized, locally manufactured silicon brains, does owning the chip foundry become the equivalent of owning the water supply in the 21st century?
That is a question every major economy is currently trying to answer.
Thank you for joining us on this deep dive into the blueprint of tomorrow. Keep questioning the technology that surrounds you, keep looking past the surface of the data, and we will see you next time.